Hello and welcome to the latest video from Lacey Maths and Stats Consultancy. My name is Sean Lacey and this video is a demonstration on using RStudio to summarize a linear model selection process. In a previous video that I have up on YouTube, I looked at presenting or using RStudio to present multiple linear regression analysis results. And in that video, initially we would have started off with a model that had 5 predictor variables. But one of the predictors was causing multi-collinearity, so the model had to be reduced to 4. And then I looked at using RStudio to kind of, present that final model. And what I would have said at the time when doing that video is that another video that would be useful, which is this, hopefully this one for you, would be the idea of using RStudio to summarize that model selection process. So how you'd end up with a model initially that had 5 predictors to actually reducing it to 4 predictors, and then it's just kind of use that kind of idea for the script that I'm going to show you here, that you could actually maybe apply that then to your own analysis if you're doing various model selection techniques. I suppose just to kind of give you an idea to what I had in mind is basically a table like this of where we could look at using RStudio to create a table like this of where there's a model initially set up that had 5 predictors. Predictor 1 was actually causing multi-collinearity. You can see here that the variance inflation factor is quite high, so it actually had to be removed. Then when predictor 1 was removed, we end up with a second model, and there was no real issue with that second model, and then that's the model that we went off and proceeded with. And then obviously when it comes to linear modeling, that you'd look at checking the residuals. Are they normally distributed? Are the residuals random? And so on, okay? But we can see here for one of them, you can see look that one of the regression coefficients is statistically insignificant, and in that previous video that I just mentioned on YouTube, I would have spent a small bit of time just talking about, look, how do you handle that? Do you remove it or do you leave it in, and so on, okay? And the decision that I came with, I suppose stuck with for that previous video was leaving this insignificant variable actually in, okay? And I suppose I explained why in that video, so I won't kind of go through it here in this one, okay? So the purpose of this video is mainly just how can we use RStudio to summarize the results for that model selection process. So if you go here to RStudio, I would have just looked at where there was a response measurement. There was 5 predictors. These were all just randomly created numbers, and then we'll just look at, I suppose, just getting a scatter the scatter plot here. So we've the 5 scatter plots. We would have spoke about it in the previous video that this first predictor 1, which is looking quite good, ended up causing multi-collinearity, so that was the one that we had to remove, okay? So just to kind of repeat those steps here to this one. So we looked at the first overall model and just highlight the script that I used there, and to the variance inflation factor, we can see for that first model there was an issue with predictor 1, very high variance inflation factor, so we removed that predictor 1. And then we ended up with that second model. When it came to the second model, everything seemed to be okay with that. There was the 4 predictors were not causing any multi-collinearity. The variance inflation factors were all quite low with them. And we spoke about how that 5th predictor was statistically insignificant, but decided to actually leave it in for the purposes of that video. And then it was at the time of doing that video, I just would have said, look, it actually can be useful to actually, I suppose, use RStudio to summarize a model selection process, which really means generating a table like that I'm showing here in this kind of I suppose slide. The other thing then that is useful when you're doing multiple linear regression is to also present your standardized regression coefficients, because there's if your regression coefficients are of different units and you're looking at potentially comparing or seeing how a regression coefficient impacts on your response measurement, then them having different units, it makes that interpretation challenging. So this is why you'd actually standardize your regression coefficients, okay? So that was just the extra bit of statistics, I suppose, that we would have generated. Here would have been the various standardized regression coefficients, and I'm just outputting the standardized regression coefficients for the second model just so we can actually see what they are here. So then the next step then was just how, I suppose, to pull all that information from the 2 models together into one table using RStudio. And I'd always find that if I want to, I suppose, create a table using RStudio, I need to have an idea in my head to what the actual table should look like. And so this was kind of the idea that I had in my head. So I was looking at creating kind of, I suppose, 7 vectors. So the first vector is just kind of the model number vector. Then there's the adjusted R squared. Then the variables that were in each model. regression, followed by the regression coefficients, followed by a vector for standardized regression coefficients, followed by the p-values, and then the variance inflation factor. And so how do I suppose, generate these 7 vectors using RStudio, and then obviously pulling it together as a data frame? That's kind of the easy step, and then writing it to Excel. So if you just look at the script here, so I first just looked at the names I was going to use. So the names were going to be intercept predictor 1 up to predictor 5. And then for the model, so the very first vector was going to be that model vector. So I looked at, I suppose, for the first model, if you look at it here, I knew that I'd have kind of 6 rows to that first model. So I just wanted 1 to be in the first row, and then all the remaining rows to actually be, I suppose, cells for that column to be actually empty. And then for the second model, I could see then that I knew that I was going to have 5 rows in that second model. So I just was looking at the number model 2 to go into the first row, and then the rest to be blank. And then it was kind of a similar idea to the adjusted R squared. Okay, so you can just see here, look, I'm saying 1 initially, so I'm creating a vector called model. The first value is going to be 1, then it's going to be followed by 5 blanks, and then I'm moving into model 2, and then followed by 4 blanks. And I'll run this all off at the very end. I won't run each line because it's just easier to kind of explain it as I'm just kind of scrolling through it. So then the second vector I was going to look at creating was an adjusted R squared. If I just look at, I suppose, so how I'm deriving it, I'm getting the adjusted R squared from the summary of the various models. So fit 1 and fit 2 were the names that I gave each one of the models. So if I just look at summary of fit 1 $ adjusted R squared, I get this output. So what I wanted to do was I wanted to convert it to a percentage and then round it to 1 decimal place, and then paste on the percentage symbol. And that's what those 2 ones are doing. So this line here, my line 48 and my line 49, is just looking at the adjusted R squared for each of the models. And then I wanted to create a vector called R squared. And the first entry in the vector was going to be the value followed by the empty cells. And then for the second model, it's going to be the value for the adjusted R squared for the second model followed by the empty cells as well. And then that was going to be the first 2 vectors. Then the next vector was just going to be the vector with the names in it. So it's going to, the first part of it was just going to be the 6 names as was actually said at the start. And then the second one was going to be the 6 names less that predictor 1. Okay, so that's what I just looked at there. So you can see here for the variables vector, I'm creating it based on names, what names were in the first model, and then what names was I going to use in the second model minus that predictor 1, which was the second entry, and then the names has been stated up here. Then the next thing then was the regression coefficient. So that was kind of a straightforward enough one. It was just looking at isolating the regression coefficients from each model. I'll just run off this one. So here you can see down in the console there is the regression coefficients for model 1, and then followed by the regression coefficients for model 2. So that was the vector I was created, was one called coefficient, and then I just wanted to round it to 2 decimal places. The next one then will be the standardized regression coefficient. So this is where you kind of had to have an idea, or you felt I had to have an idea in my head to what the result should look like. So when I look at this here, for my standardized regression coefficient, I knew that there should be no standardized regression coefficient for the intercept. So I should have a kind of a blank cell, an empty cell, then followed by the 5 regression coefficients, standardized regression coefficients, another blank cell, 5, and then this case will be the 4 standardized regression coefficients. And then that kind of same structure would stick with the p-values and for the variance inflation factor as well, where the first entry for each kind of row would be empty because it was relating to the intercept in both cases. Okay, so that brings me down here. So I looked at creating, I suppose, this was the output for this, the standardized regression coefficient for model 1. This was the output for the standardized regression coefficient for model 2. I rounded them both to 2 decimal places. So blank cell, what are the regression coefficients? Blank cell, standardized regression coefficients. Then the p-values is a similar idea. So I first had to have a blank cell, an empty cell, and then what the p-values were. So I'm just going to highlight this. Where is it here? Summary fit 1 $ coefficients. Just so if I run that off, you can just see that that outputs the 5 p-values. I just wanted to round them to 4 decimal places. Sometimes your p-values can be quite small that RStudio might present it in scientific notation. So I'm just kind of putting in this kind of insurance kind of policy that if the p-value is less than 0.0005, then state it as less than 0.0005, otherwise round it to 4 decimal places. So that's what I'm just doing here. I'm looking at creating a p-value vector with a blank cell initially, then the p-values from the first model in the format that I wanted to be in, blank cell, p-values from the second model. And then the last one then is just the variance inflation factor. So it has to be blank, an empty cell initially because there's no variance inflation factor for the intercept. And then I'm looking at just rounding my variance inflation factors to 1 decimal place, for model 1, so they were created up above in the previous when we were looking at generating the model at the start, and then for model 2 as well. And then it's just pulling all the vectors that I've looked at creating there, the 7 vectors, into this one kind of data frame. So I'm just going to highlight all this in one go here, and everything should work out okay. And here we end up with it. And it's like everything with RStudio, it can take a while to kind of end up with script that you're kind of happy with, but then once you actually have that script, it's very useful then kind of going forward. And you could then, if you ended up wanting to reduce another variable, you can just look at adding on, I suppose, another part to each one of these vectors, and that's what you'd be looking at doing. So at the moment, we've kind of 2 parts to each vector, and if you're looking at reducing the model even further, then you'd add a 3rd part to each vector. That's what you'd look at doing. The next step then after this then would be just, I suppose, writing it to Excel, and then just looking at doing the final bit of formatting. There's always going to be formatting to tables and graphs, no matter, I suppose how many times you're going to be kind of doing something quite similar. There's always going to be a bit of formatting where it's going to be decimal places or changing the names and so on like that. Okay, so I've written that to Excel. I did. So let's come here to the folder where it is here. Look, table LMS for linear model section. You can see here I have 2 other tables. They were from the other videos that I've up on YouTube. The first one was the simple linear regression, presenting results for a simple linear regression model, and then the multiple linear regression model. And that's what those 2 videos were, I suppose, demonstrating, is just how we can use RStudio to present those models. Okay, but this is one. For this, we're going to look at the linear model section. So this is what we have. I'll zoom in a small bit like this. That should be okay. And there's always a small bit of formatting that you're going to do. So you can just see that the numbers here didn't actually come in as direct numbers, so I just need to convert them to numbers here. That's first. I don't need that one here, so I'm just going to remove that. There's usually a bit of decimal places needs to be set. So my percentages, I wanted them to 1 decimal place, so I'm going to fix them up. The regression coefficients, I want them to 2 decimal places. You can see here, this one, when your second decimal place is 0, you lose it in Excel. So I don't like that. I like when everything looks nice and in line with the decimal places. So I'm just going to line them up a small bit. Actually, I went in the wrong direction there. It's like that. The p-values, I want them to 4 decimal places. You can just see here, Excel just treated that one a bit strange. So I'm just going to tidy them up. That's 3 decimal places. There's 4, and then I'm going to align them to the right in each cell. So that looks okay. And then the last one will be the variance inflation factor. You can see this down here at the second last one. It's coming in as 2, and obviously I just want it to be 2.0. So I'm just looking at just tidying them up a small bit. But I'm not changing any of the numbers. I'm not typing in any of the numbers myself. And that's what I've really tried to, I suppose, encourage, is that if you're creating tables from your data in RStudio, try not to be creating the tables manually in Excel or in Word. Try to actually create the table in RStudio, because then you have the transparency for whatever the data is in that table. Okay, that if anyone was calling into question some of your results or anything like that. Okay, and then the last bit is just kind of, I suppose, it is just kind of a lot of merge and center. Okay, so I'm going to press OK here to this. Actually, I'm going to just put this on mute here, because when I press the merge and center, it's going to continuously keep binging. So here like this one next. I'll look at centering all these now in a second, like that. And look, this is where everyone has their own kind of personal taste to how they might like doing things. Okay, but I'm just going to try to have it in line with what was actually stated there on the slide. So adjusted, that's correct, or capital R, and then I'm going to just put in the symbol or squared. Perfect, that's that done. Okay, we're okay with that. And just widen that a small bit. Perfect. Variables, so just widen that a small bit. This is going to be regression coefficients, is what I want to call this. Okay, like that. That seems okay. I'll look at wrapping this text now towards the end. So standardized, this will be ADDIS regression coefficients. P-values, I'll just put a hyphen in between there, like that. And the variance inflation factor, I'm okay with all that. I'm going to center them. I'll center them all, and what I'll do there is I'll just wrap the text a small bit. Now it just makes it a bit bigger, but I will just widen these a fraction in each case, and then I'll tidy up that. So yeah, that looks okay like that, and then bring this up here, and that's looking much better. I'm just going to line these in the center. I think that looks nicer. And then just to make it similar to, I suppose, the table on the slide, that's what I have here. And then I'm just going to highlight these, right click, format the cells. For the border, for the outline, I generally do a thicker line for the outline, and then I do a thinner line for the inside, like that. And that looks quite similar to what I have here. Okay, and again, there's always going to be that bit of formatting to a table, but I think it's what I suppose hopefully you can just see from this is I wasn't actually inputting any of the numbers myself manually, and I think that's kind of what I suppose I wanted to just maybe demonstrate how we could actually do that using RStudio, how we could look at nearly creating a table manually in RStudio so that we have the track record, we have the transparency for the generation of that table, and then we write it to Excel, and then obviously from Excel it can go to wherever you want it to go then after that. Okay. So yeah, that seems okay. That's all seems to be in line. And look, that's the end of this this video. I just felt when I was doing that second video on the presenting the results for the multiple linear regression model, and we ended up reducing, I suppose, the number of variables that was in the original model. I said it at the time that it would be useful to actually generate a table that would kind of keep track of that model selection process. And this could be something if you're doing a PhD that you might like to, I suppose, present those results. You might want to put them into an appendix, so there is just that transparency of how you ended up with, I suppose, a model that had 5 predictors, or it could be obviously more, and you ended up reducing it step by step. Okay, and that's really it. And like all these things with RStudio, there's more than one way of doing something. So if you feel that you actually have encountered the same issue, but you have more efficient codes than the one I'm looking at here, then by all means, commenting below would be great, and kind of sharing that information would be absolutely brilliant. If you like the video and you like kind of the direction and kind of the information in the video, then liking and sharing it is good. And as always, if you subscribe to this channel, then you'll get the updates to when there's going to be more videos uploaded to YouTube. Okay, but for the moment, I hope you found that this video will help, and I hope it will help you in your own research. And till next time, all the best.